Let's find the exact values for nested inverse functions. So nested inverse function, it just means that I have a trig function inside an inverse trig function or vice versa, and we just need to go through and evaluate. So when we're doing these, always start from the inside. But for number 1 and 2, we've got a special case because you see we've got the inverse sign and regular sign right next to each other. These are inverse operations. So since they're inverse operations, they undo each other, and we are just left with the inside, that negative pi over 3. But it's not that easy. So negative pi over 3 could be our answer. It actually is our answer in this case. But when we're doing this, since it's arc sine, we have to remember the boundaries. The boundaries for arc sine are from negative pi over 2 to pi over 2. So we have to check and make sure that negative pi over 3 is within that. So we go here. Okay, negative pi over 3 is definitely in those boundaries. We're in the clear. Negative pi over 3 is our answer. Same thing happens with the next one. I got arc sine of our angle measure. So when we go through, okay, these two are inverse operations. They undo each other. We're just left with the angle on the inside. But this time when we go to draw the angle on the inside, to get to 5 pi over 3, we have to go out of bounds, and then back in bounds to get there. That is not okay, right? We have to stay in bounds the whole time. The boundaries, again, for sine, negative pi over 2 to pi over 2. So instead, we have to start at 0 and go backwards to get to 5 pi over 3. Well, what do you know? That's equal to negative pi over 3. When we have two different trig functions nested within each other, well, then we have a little extra step. We're still going to start at the inside. I'm going to look at arc cosine of negative square root of 3 over 2. So I'm starting with arc cosine. So we're like, at what location does cosine equal this? And we go to our unit circle. And we see that, okay, cosine equals negative square root of 3 over 2 at 2 locations. Looks like that happens at 5 pi over 6 and 7 pi over 6. The boundaries for arc cosine, though, remember, are from 0 to pi. So 5 pi over 6 is the one that's in bounds. I can now replace 5 pi over 6 with the arc cosine of negative square root of 3 over 2. So we're left with tangent of our answer to the one on the inside. And then we just need the tangent of 5 pi over 6. So we're looking, tangent of 5 pi over 6. Well, that is equal to negative square root of 3 over 3. Final answer. The ones that are really fun are ones like number 4 and 5. So number 4, I go and I'm looking at the inside just like normal. I'm looking at the arc cosine of 7 over 25. And I go to my unit circle. 7 over 25 is not in our unit circle at all. So this one's a little different. We're going to have to utilize our SOHCAHTOA. So go ahead and draw your coordinate grid. You can skip the circle, but we're looking at cosine, arc cosine. So we know we're looking in quadrant 1 and quadrant 2 because of the boundaries starting on the inside. And we're going to draw a triangle. The arc cosine of 7 over 25 means that the adjacent side is 7 and the hypotenuse is 25. So I go over 7 on the x, I go down however much, and then my hypotenuse is 25, and I can create this triangle where this side length is 7, this side length is 25, and then this is theta. We can't just go to the calculator for this one because the problem asks for exact values. That's why we have to draw this triangle. Well, our goal is to find the tangent. I can't figure out what theta is, but I can figure out what the tangent is given this information with this triangle. Tangent theta, remember, is equal to opposite over adjacent. So all we need is this opposite side over here, then we can find the tangent. Well, in order to do that, we'd have to do the Pythagorean theorem, or we can remember the Pythagorean triples. This one is my favorite, the 7, 24, 25. So we can fill in that side as 24. Tangents opposite over adjacent, so our final answer here is 24 over 7. We're using the inside to draw the picture. All right, so if you want to, we're going to draw this triangle, and then we're going to solve for this one. Remember that order. Always start from the inside, draw or go to the spot for the one on the inside, and then try to solve the one on the outside. Go ahead and give number 5 a try. You got it.